In this video lecture, we will look into the chemical properties of alcohols. When we talk about chemical properties of alcohols, we mean chemical reactions, right? And we know that chemical reactions are nothing but breaking of bond and making of bond. So in order to understand the breaking and making of bond in alcohols, or we say chemical reactions in alcohols, we need to understand first the structure of alcohols, how bonding takes place in alcohol, or how, so that we can understand how bonds can break in alcohols, right? So let's first understand the electronic structure. We have done the structure of alcohols in the previous lecture, right? So we'll just take that in brief, right? This is how an alcohol, let's take methanol. Right, here I have O, you have H, right? Now we know that since we have electronegativity difference between different atoms, in this bond, electronegativity is higher on oxygen side. In this bond, OH bond, electronegativity is higher on oxygen, right? Electronegativity of oxygen is higher. So when the electronegativity of this atom is higher in this bond, it will pull this shared pair of electron towards itself, right? Thereby making this bond polar, right? So this shared pair of electron will move towards itself, thereby giving it a small negative charge. It will get a equal small positive charge. Similarly, in this bond, electronegativity of oxygen is higher, due to which it will again pull the shared pair of electron of this bond towards itself, acquiring a small negative charge, and this will acquire a small positive charge, equal small positive charge. Now we have polar bonds, right? Polar bonds in alcohol molecule. When we say polarities, we have positive and negative sides, right, in alcohol molecule. So when you have reagents like OH, hydrogen, right, provided by different reagents, these polar reagents, right, or these reagents, right, reagents that can give your OH ions, right, for example your sodium hydroxide, these can now easily attack these polar bonds, right? Now we need to look into the chemical reactions of alcohols, right, due to this bond, right? Since we know that polar bonds, right, polar bonds can easily be cleaved, can easily be broken, right? That gives high reactivity to the molecules, right? So polarity gives high reactivity to the molecules, right? Just understand one basic thing. If we talk about this bond, you have OH, right? It is made up of, we have a shared pair of electron, right, which should be ideally at the center, right? When this shared pair is at the center, both the atoms will attracted with equal force, right? So this shared pair of electron will hold these two atoms together. But if due to something this shared pair of electron will move more towards this atom, right, now attracts, suppose it now comes here, right? Now distance of this shared pair of electron from hydrogen has decreased, thereby the attraction between shared pair of electron and this hydrogen atom is also decreased, right? Due to which now the shared pair has less hold on this hydrogen atom, due to which it can easily be, this bond can easily be broken now, because this hydrogen is less attracted by this shared pair of electron. So this hydrogen can be easily lost from this alcohol molecule due to polarity of this bond, and polarity has resulted due to electronegativity difference, right? So this can be easily lost as hydrogen ions, right? So in general, electronegativity difference will introduce polarity in bonds, and due to polarities bonds can be easily broken, right? Since bonds can be easily broken, so the molecule would be reactive, right? So in short, polarities will increase reactivity of molecules, right? I'll just mention it over here. Polarities will increase reactivity of molecules. Why? Because these polar bonds can be easily broken. Since polar bonds can be easily broken. Now if let's look at this bond. We have seen this bond, right? Now let's look at CO bond. In CO bond also, like I said, there is electronegativity difference between carbon and oxygen, due to which oxygen has acquired a negative charge because oxygen has high electronegativity, right? And carbon has your equal positive charge because it has less electronegativity. So now this shared pair is more towards oxygen, like this, right? Due to which again this bond is now polar, right? And now since this shared pair has shifted more towards oxygen atom, now carbon has less hold, or this shared pair has less attraction for this carbon atom, due to which this bond can now easily be broken, right? This bond can easily be cleaved at this end, from this end, right? And since here also the similar condition we have, this pair is more towards, shared pair is more towards oxygen, this bond can also be broken easily, right? So this is important thing, right? Second thing, important thing is, now there are, since I said that chemical reactions are nothing but breaking and making of bonds, right? Now we have seen that alcohol molecules can be cleaved or broken from this end, between O and H bond, right? Or between C and O bonds. So there are certain chemical reactions where we will see that this OH bond breaks, right? And other reactions where CO bond will break, and some other reactions where you have both alkyl part and your OH part involved, right? So generally we have three types of reactions. In alcohols, right? First type, where your OH bond is involved, right? Like this. Second reaction is where your ROH bond is involved. ROH bond, or we say CO bond, this bond, CO bond is involved. Third is where both R and OH is involved. That is, in the third case, complete alcohol molecule is involved, right? Now let's first talk about the first, where your OH bond is involved. Like I said, this OH bond will become polar, right? Due to electronegativity difference, this OH bond will become polar. Since it is now polar, so OH bond is your weak bond, right? Due to polarities introduced, your bond has become weak, right? And since it has become weak, let's say we have R here, it would be broken into ROH hydrogen ions, right? Since this bond has grown weak, right? Because now it has, a polarity has increased due to electronegativity difference, right? Since this bond has grown weak, so it will break, right? OH bond will break, releasing hydrogen ions, right? Like this hydrogen ion will release, right? Since we know that acids release hydrogen ions, any acid, we have studied this in previous classes, that acids are those chemicals that release hydrogen ions. So here alcohols are also releasing hydrogen ions, right? So we say, since alcohols release hydrogen ions, they act as acids, right? So alcohols are acidic, right? They are acidic because of the presence of OH bond, right? And we know that OH bond is polar bond due to electronegativity difference and is weak bond, right? So hydrogen can be released from this OH bond, right, making alcohols acidic, right? Due to release of hydrogen ions, alcohols are acidic, right? That means if we say that alcohols are acidic, they will give some reactions similar to those of acids. For example, if you remember, sodium will react with hydrochloric acid to give you sodium chloride and hydrogen gas. That means if I react CH3OH with sodium, right, let me just write it like this, OH bond, CH3OH, this is methanol molecule, right? Now since I said that OH bond is weak, right, so this is in this reaction is first type reaction where OH bond is involved, right? So here this bond will break, right, and it will form methoxide ion and hydrogen ion, right, and product would be CH3ONA, sodium methoxide plus hydrogen gas would be released, right? So when alcohols react with metals, hydrogen gas is released, same as when metals react with acids, hydrogen gas is released, right? So here acid and your alcohol giving same reaction because alcohols also behave as acids, right, releasing hydrogen ions, due to which hydrogen gas is released. Now let's look into some other reaction where it acts as acid, right? Reaction with metal hydrides, right? If we react methanol with, say, metal hydride, sodium hydride, in hydrides we know hydrogen is present as a negative ion, it will again form CH3ONA plus hydrogen ions, right? So same as acids. And the other important reaction is reaction with Grignard reagents. Let's say ethanol react with Grignard reagent to form methane, right? Here also OH bond is involved, CH3CH2OH, right, CH3MgBr, right? This is your Grignard reagent, methyl magnesium bromide. This is your Grignard reagent. Now here also this reaction is also type first reaction where your OH bond will break, right? And we know that this is plus, this is minus, this is minus. Your hydrogen will react with methyl to give you methane, right? And here you have this is what you will get, right? So this here also OH bond will cleave. Now reaction with, let's take an example, important reaction which is your esterification, where ester will form, right? It reacts with acids, for example acetic acid, this is the formula for acetic acid. It reacts with alcohol, right, say C2H5OH, right, OH. Here also H is involved, so OH from here and H, this bond will break, releasing hydrogen ion, right, giving you this compound CH3. This is an ester, plus OH and H will react to give you water. This is a famous esterification reaction which take place in the presence of concentrated sulfuric acid. This reaction occurs in presence of concentrated sulfuric acid because we know that concentrated sulfuric acid act as a dehydrating agent, and we have water getting formed in this reaction which might start your reverse reaction, right? So what concentrated sulfuric acid will do, it will remove water, right, and will keep the reaction going in forward direction, right, towards product, right? So this is the example of a reaction where your bond OH is involved. Right, now reaction with acid chlorides, right, acetyl chloride. Let's look into one reaction with acetyl chloride, CH3, right, COCl, right, reacts with, say, let's take its reaction with a simple compound, ethanol again, right, ethanol, right, this is how it will form an ester plus HCl. You can see this bond cleaves, right? Just look at what we are trying to understand, the cleavage of OH bond. So here also you have an ester, same as here, right? So this bond also involves cleavage of OH, right? And this reaction takes place in the presence of pyridine, right? And this reaction is known as acylation. We call this reaction as acylation. Right, this is your acylation reaction. Just remember the name. This reaction is your acylation reaction, because this involved an acyl group. This CH3CO, this is your acyl group, right? And this acyl group is replacing hydrogen, right? You can see that this acyl group CH3CO has replaced hydrogen. So this reaction is your acylation reaction, because it involves the replacement of hydrogen by acyl group, right? I hope this is clear. Now let's look into the other type of reactions. Other type of reaction where only your H group is, where your CO bond is involved, this bond is involved, right? And one thing in this case, right, in the first case, we know that alcohols can act as acids, right, and they can act as bases as well, right? Alcohols can behave as nucleophiles and your electrophiles, right? So when we say nucleophiles, they will attack positive sites, right? For example, here, if you look at this, it's in this reactions, alcohol is acting as acids also, it's as nucleophiles, right? Because here your this bond breaks. When this bond breaks, hydrogen is released as positive ion, and you have acetyl group, the CH3, you have this group, this is your negative group, right? And if you look in this reaction, right, in this reaction, when this bond breaks, right, this is your plus, this is your minus, because here also you have oxygen that has high electronegativity. So this negative, when this hydrogen will release, it results into a nucleophile. This acts as a nucleophile, because it will attack the positive sites. It will attack this site, resulting into this compound. So in your reactions where OH bond is involved, alcohols act as nucleophiles, right? Now we'll look into reactions where your CO bond is involved, right? Where your CO bond is involved. Now since here you can see you have your carbon and oxygen, right? Between carbon and oxygen you have polarities. This bond gets weakened, right? So this bond can be cleaved from here, right? Because the electron displacement is more towards oxygen, right? Thereby this bond is now weak, so can be broken, right? So the COH bond can be broken. Now we'll look into reactions where your COH bond is involved, right? And in such reactions where CO bond is broken, right, the reactions where CO bond is broken, alcohols act as electrophiles, right? So alcohols are versatile compounds. They can act as electrophiles as well as nucleophiles. This is an important point, right? So when your COH bond is involved or the COH bond breaks, your alcohols act as electrophiles, right? Now let's say this is H, O and H. Right. Now let's look into the reactions where your COH bond is gets broken. Right. So here just look at one thing, that understand the nature of your R group. Right. We know that alkyl groups are electron releasing group. Right. Here this group is your electron releasing group. Right. So when this group releases electrons, right, towards carbon of OH, the alkyl groups, they repel electron towards carbon, right? So electron density is increasing on carbon, right, which will again then repel the shared pair towards oxygen atom, right, of OH, and this increases the polarity of COH bond and makes its cleavage easier. This is an R group, alkyl group. It releases it releases electron towards carbon atom. When it releases electron towards carbon atom, it's increasing electron density, that is, it increases negative charge on electron, right? And we know that in this bond, electrons are already more displaced towards your oxygen atom, right? So when you have negative charge, right, when you have negative charge increasing due to this R group, right, so this electron pair would be more displaced towards this oxygen atom. That means it is increasing the polarity, right? This R group is increasing polarity between carbon and oxygen, thereby weakening this bond. So here, important thing, presence of R, right, due to plus I effect. Plus I effect is inductive effect. When your alkyl group releases electron, it is plus I effect, right? Presence of R group due to presence of alkyl group, right, due to plus I effect increases electron density on carbon, right, of alcohols, increases electron density of carbon, right, thereby repelling electrons towards oxygen of OH, right, due to which bond polarity, right, polarity between CO bond increases, right, and increases, making its cleavage easier, right? When this bond is easily broken, that means it is more reactive, right? That means it is more reactive. So if more the number of R groups, alkyl groups I have on alcohol, more is the reactivity, right? So I write it like this. So reactivity of tertiary alcohols would be maximum, right, because I have maximum R groups, all are electron releasing, right? So all these in this CO bond will increase electron density, right, on carbon, which will displace the shared pair more towards oxygen atom, thereby increasing the polarity of CO bond and making its cleavage easier. Right, so this would be less reactive. We know that this is 3 degree alcohol, this is 2 degree alcohol, this is your 1, then this is 1 degree, and methanol would be least reactive in terms of CO bond, right? This is the order. Now let's quickly look into some reactions. Now we are clear how this bond gets broken, right? Due to electronegativity difference, polarity increases, so now the cleavage is easier. More are the number of alkyl groups, more is the displacement of this electron towards oxygen atom, so more is the polarity and easier is its cleavage, right? Some important reactions are like reaction of say CH3OH with HCl, right? Here your CO bond will break. Let's look into the structure form. This is your methanol. Here your CO bond will break and your OH and H will form water plus your Cl. Right, the other reaction is, we'll be looking into these reactions in more detail in other lectures. Reaction with phosphoryl chloride, like CH3 CH2OH, this is ethanol. This reacts with PCl5 to give CH3 CH2, give you OCl. Right, CH3 CH2 Cl. I'm sorry, not O, CH2Cl, Cl. Right, since this is the breakage of OH bond, it will break, Cl will come here and it will form plus POCl3. Right, phosphorus oxytrichloride, and then you have HCl. This is an important reaction where your CO bond cleaves. Right. The other reaction is, let's look into one more reaction. Reaction with ammonia. If we look into the reaction of an alcohol, let me just rub this off. Reaction of say methanol with ammonia, it will cleave the CO bond again. You have CH3OH plus HNH2. This is ammonia, right? Your bond breaks, water will release and it will form an important organic compound. These are amines, right? So these are the reactions where your CO bond cleaves. Now there are certain reactions, like I said, where the entire molecule is involved. The third type of reactions where both R and OH is involved. The famous reaction is the dehydration of alcohols. Right? Third type of reaction where R and OH is involved, your dehydration of alcohols. Right? Now here let's just do it like this. CH3CH2OH, right? Here in the presence of concentrated sulfuric acid. Now look at this. Here I said that entire molecule is involved. Alkyl group as well as your OH is also involved. Right? So your CO bond is also involved and your alkyl part is also involved. Right? Here it will form ethene with the elimination of water molecule. You can see the water molecule would be eliminated and this is left, which is your ethene molecule, right? I hope all this is clear. In this reaction your entire molecule is involved, you can see, and with the formation of ethene molecule. This is also involved and this part is also involved. I hope this is clear. Thanks.